So in this video, I'm going to be reviewing how to draw Lewis structures, how to draw it correctly using the Vesper model, and then how to determine whether the molecule is polar or nonpolar. So let's look at this first example, NO2+. Okay? So nitrogen has 5 valence electrons, oxygen has 6, and there are 2 of them, but notice there is this plus charge, and what that plus charge tells me is I actually have 1 fewer electron, valence electron. So 5 plus 12 is 17, minus 1 is 16. Okay. My next step is to draw this out and share electrons between the atoms. Then I need to make sure that all of the atoms have a complete octet. So I've got 2 valence electrons here, 4, 6, 8, 2, 4, 6, 8, and the nitrogen has 2, 4, 6, 8. So let's see how many valence electrons I'm using right now. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm using too many. And so as soon as I know I'm using too many valence electrons, I'm going to need a double bond. So if I draw 1 double bond here, in order for oxygen to still have only 8 valence electrons around it, 2, 4, 6, 8, I've got to get rid of 2 valence electrons here. Then for nitrogen, I've got 2, 4, 6, 8, 10, so I've got to get rid of 2 here. Then if you notice, let's count electrons again. 2, 4, 6, 8, 10, 12, 14, 16, 18. I'm still using too many, which tells me I'm going to need another double bond. Okay? Since I added another double bond, nitrogen now has 2, 4, 6, 8, 10. That's too many valence electrons, so I'm going to get rid of those 2. And oxygen has 2, 4, 6, 8, 10. Too many, so I'm going to get rid of those 2. Okay? And so I now have 2, 4, 6, 8, 10, 12, 14, 16 valence electrons. I'm good to go. Let's quickly look at what that structure will look like using the Vesper model. And remember, the Vesper model tells us that the molecule will assume whatever shape minimizes electron repulsions. So what exactly would that look like? All right, for NO2+, I have 2 double bonds, which is exactly how we drew it previously. All right, so the last concept, since this is the correct model, is for us to determine whether it's polar or nonpolar. Remember, atoms will attract electrons with different force. So what I like to imagine is that oxygen is pulling the electrons towards it. That's its dipole. It creates a dipole. This arrow is a dipole. And so since it is pulling electrons towards it this way, but then the other oxygen is pulling it in the opposite direction, nitrogen itself will not move in that tug of war. And when when an atom does not move in a tug of war, we say that the molecule is nonpolar. We can't say because it doesn't move in a tug of war. So instead what we say is it is nonpolar because the dipoles cancel. Okay, let's look at the next example, SF2. My first step is to determine the number of valence electrons. Sulfur has 6 valence electrons, fluorine has 7, but there are 2 fluorine atoms, so I have a total of 20 valence electrons. I'm now going to share my electrons, so I've got sulfur and fluorine, and another fluorine. They're going to share electrons. Okay. Then I need to make sure everyone has an octet. So fluorine right now only has 2, so it needs 4, 6, 8, 2, 4, 6, 8. Sulfur has 2, 4, 6, 8. Okay? Right now I'm using 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 valence electrons, so I'm good there. Let's double check my model to see what this will look like using the Vesper model. So for SF2, I've got 2 atoms bound to it and 2 lone pairs, and so this is what the molecule looks like. Okay. And what we just saw is this in all of my artistic ability. Okay, so it looks like that. So if you imagine fluorine pulling electrons towards it, and this fluorine pulling electrons towards it, imagine in a tug of war, nothing's going to be pulling upwards to counteract that. So in a tug of war, sulfur would move ultimately downwards in that tug of war. And so since it moves, we say that the molecule is polar, and it is polar because the dipoles do not cancel. So I'm hoping now you see why it's so important to draw it properly, because if we had drawn SF2 like this and then said, oh, look at my dipoles, they cancel, then you would have said that the molecule is nonpolar, when in fact it's polar.